My name is Illarion, and I'm a web developer and an e-commerce specialist. I work primarily with a Shopify service. We're building custom stuff, ranging from custom visual design from complex business logic on demand. So during the last 2 years, practically every project involved multi-step forms, or so-called wizards. And I wanted to share my experience building them tonight. A wizard is a step-by-step process that allows the visitor, or the customer in our case, to complete something for a first time in a controlled fashion. For example, if they want to order a product that is configurable, like a bicycle, and they would like to have a custom chain or some extra features in it, and but they are doing it from time to time, not always. So a wizard works well to guide the customer through those steps. Like step by step, it's a controlled thing. They choose what they want to buy, and they come to the end of their journey. Wizards are similar, are a synonym to the user journey, and they can feel comfortable along the way. So if you have encountered wizards, if any one of you has installed a Windows program at any point in your life, you've seen a wizard. So you click setup.exe file, and you're presented with a window with next and back buttons, and you press next, and you select where to install it, how to install it, and etc. So this is exactly is a wizard. So in our work, we were tasked to create such things, and of course it's different. There is a special tooling available for Windows programs, but there is no ready available. There's little available tooling for web development in this sense. So I started with the first project. I started researching how to do it. And if you're building a small multi-step form, like you have 1 or 2 or 3 steps, it's straightforward. You get the steps, you get 3 forms, you upload all forms to a server, and you're done. But if you get to a point where you have like 5, 6, 7 steps, then you start to think about how to optimize it. For example, the customer might not need to take all the steps. Back to the Windows program. If you don't want to customize your installation, you can just skip all the steps and get right to the finish and press install. Like choose the defaults. So we wanted something like that. Our clients wanted something like that, so that some customers that do not want to have customization could just jump right to the end or use a shortcut. But you can imagine how much complexity it adds to our initial simple form, because now you have to branch out your logic tree. For example, so does the user take this step or not? And if not, where do they go exactly? And what if they decide to go back? How do we treat that? What if they want to? That's a real client requirement, that the customer would be able to jump from any step to any step. Like if they're at the very end and they would like to change the bicycle type, they should be able to jump right to the beginning and change it. To be clear, we haven't built anything bicycle related. It's just I have a demo in store for you, and it will involve bicycles.
attempt was
with a Redux-based wizard, and it works it worked and it works reasonably well. Yes, but I had this through the whole process, and after we completed the project, I had this nagging feeling that something is incomplete, so that there are some gaps in the logic that might prevent the customer from completing the journey, or maybe even what's worse, the customer might find themselves in a limbo. I decided to call it like that, a limbo. So, like, you know, there's a step A and a step B, and the user should go from step A to step B, but instead they don't arrive at B, and they are no longer at A. So they are in limbo. And what's bad about limbo, not only that they're in the middle of nowhere, in the middle of things, is that that the user and the owner of the program and us too might not realize the user's end in that limbo too, because it's an indeterminate state that doesn't mark itself as an error, and so it's not easy to track. So when I was working with a Redux-based wizard, I constantly felt this nagging feeling, this pressure, like this dread, that I cannot guarantee that people will be able to complete this thing. So it worked. I even had tests in place, and with every update, I went through all the steps and I tried the logic. And you know, like the anecdote goes, like a QA engineer goes into a bar and orders 1 beer, minus 1 beer, 922 beers, orders a lizard, and everything's all right. And then the first real customer enters the store and asks where the bathroom is, and the bar is on fire. So I had this feeling all the way. And I'm a big fan of Redux and other approaches. You could go with React State, you could go with practically any solution that involves some kind of state storage, Mobix, unstately, you name it. The problem is that you cannot quantify those states and measure precisely the logic of moving from part to part. And why is that? It's because all those models that I've tried were infinite state machines. They were state machines, and I'm switching to a definition of a state machine now. But they were infinite state machines. A state machine is a mathematical concept where you have a state and you can have multiple states, but you're in one state at a given time. And Redux foots the bill ideally. Well, if you do the reducers right and your actions are sound, at any given point, your Redux state, your Redux is in a particular state. But the problem is, there are two types of state machines: finite state machines and infinite state machines. And Redux is an infinite state machine, which means you cannot calculate how many states there are in general. So you are sure that you're in one state at a time. You are sure that there are multiple states, but you cannot quantify them. Because Redux by design can contain arbitrary data. So if you have like a form data in a Redux store or React State, I know not everyone loves Redux like I do. The user can input anything into those fields, and so it means you can have anything in your data. You have the shape of the data, you have a deterministic, like Dan Abramov says, way of updating those data points, but you cannot tell what ends up there. And this means it's an infinite state machine. On the other side, there are finite state machines that have a limited, a finite number of states that you can quantify. It can be as simple as two states, like a door. It can be a little bit complex, like the popular example of a traffic light. You can have green, red, and yellow, and blinking yellow. So that's 4 states. And you can get as ridiculous as you want with a state machine like this. So it's a Rubik's Cube. And I even have a note on how it's a finite state machine. Yeah, it fits the definition. It's a finite state machine. It has 43 quintillions, 252 quadrillions, 3 trillions, 274 billions, 489 millions, and 856,000 exactly states. Yes, but it's quantifiable. It was proved that this is the exact amount of states that a Rubik's Cube, this particular, I know you can have four tiles on the side, but this, the classic Rubik's Cube contains this much, can have this much states. And it has a finite state, finite number of actions. There are 10 actions. Left side clockwise, counterclockwise, right side clockwise, counterclockwise, top, bottom, and back. So that gives you 10 actions or transitions that give you this ridiculous number. So, in fact, when I was researching state machines for this talk, well, I was already convinced that it works, that it's a great thing in general and for wizards in particular. And I wanted to give a good example. I scoured the web for materials. I watched videos, I read articles, and everyone was giving that traffic light example or our turnstile. Turnstile is also popular. Maybe a door. A door was a good example, but I found my bestie. This is my favorite machine, and it's unbreakable. So back to our details. I found the culprit. That to be sure that my wizard logic is sound, I need a finite state machine. So I started digging. I watched video, as I said. I was impressed by David Khurshid's talk. I'll give a link to his video from ReactConf at the end of mine. And I was convinced, I was sold, and what's better, David created a library called XState that produces state machines and state charts. So I decided to give it a try. I tried to build, that's a good point. I tried to build my first state machine, my first wizard using XState. And then I ran into some problems. I found I felt that mind me that was 2 years ago, and XState is much more mature now. But when I worked on it, it had a more academic feel, so you could produce diagrams from the state machine definition. So you take a JS object, you define your states and actions in a JS object, and then you can print out the diagram. And that was great and all, but it required extra efforts. It required like a special interpreter to make the machine work. So I was a bit stuck. Yeah, I'm on time. So I was a bit stuck, and then I found the next best thing. It's a library by a Bulgarian developer, Krasimir Tsonyev. It's called Stent, and it had everything I wanted to have. So this is my recommendation for wizards and state machines, and it worked just fine for me. So 2 details. During my research, I compiled a list of requirements. So to translate client requirements, like business requirements and technical capabilities into a checklist. So for myself, please note that this is my personal experience. Your mileage might vary. For me, a perfect wizard would be deterministic. In essence, I would get the same state for the same actions with the same parameters. The wizard would insulate itself from external factors, so that only prescribed actions, just like Redux does, only prescribed actions would affect it in a controlled way. A perfect wizard would support logical step jumping. As I said before, if there is a need for the customer to jump to the very beginning, it should be done. It should be able to save and restore user progress, handle asynchronous actions, and as a cherry on top, be self-documenting and easy to test. So I can say I covered all those things for me in my current approach. Sorry. And I would like to share some more details. So I covered Stent. Stent is a good library because it's asynchronous by default. It utilizes generators under the hood. So asynchronous actions using promises inside state transitions is straightforward. It's isolated. You can have as many machines as you want. You can clone them and they can communicate between themselves. You can integrate step jumping and saving and restoring user progress relatively easy. I settled on Stent and started building my thing. During the implementations, several things didn't work for me. So one of the first issues I encountered was I wanted to use React Router for declarative route-based rendering. I'm sure most of you are familiar with it. So when the newest React Router allows you to re-render a part of the page based on the specific route instead of having a global route for the entire page. Well, you have a global route, you have a URL for a specific page, but different parts of the page can render different stuff based on your routing logic. And that's a good thing, and you wouldn't want to lose that. Yes, so I started doing that in my wizard. So my wizard would update the browser history, so it would have routes. It's logical. Steps can have routes. It gives you a nice view. You can utilize router-based rendering. But at the same time, I had another nagging feeling that what if the customer decides to change the URL? Or what if they copy the URL from the middle of the wizard, like they're on the third step and it's a URL like step 3? And they copy the URL and then try to get back to it. So in a vanilla React router, that would mean that my page would update, but the wizard didn't update. So we isolated it, so it runs on a state machine. It decides itself where you are, but now you have another source of truth from the route. So I tried a logical thing. I tried blocking, history blocking. So I decided that I would override the URL every time it changes. So it changes, I look at it, oh, it's not right. The wizard overrides it The wizard imposes itself on the route, and all is well. It works, but to a certain extent. Well, first of all, if you reload the page, everything goes down the drain. And the back button still is not blocked. So if you click back button, you either go back elsewhere outside the wizard, or you just get stuck in that step. So you're basically blocking the back button. That's not good. That's not coherent. The behavior is not coherent. And I'm not the only one agreeing that history blocking is not that beneficial. Ryan Florence has created a reach router, which I recommend, and in my latest work I've settled on the reach route instead of reach router, instead of React router. And he specifically says that history blocking is not available in reach router because it doesn't work all the time. So what do we do if we want to keep our UI rendering based on routes, but we don't want to do all this black magic to override the routes? And I found a solution. You can have send allocation information to the reach router and to the React router using their server rendering capabilities. So instead of updating the URL in any way, I just have an internal path inside my wizard, and I pass it on to reach or React router, and it behaves as if it's the actual URL. And I can have regular routes elsewhere outside the parts of my wizard, so it doesn't break routing for the entire app, and it's a nice way to control things. So as I said, route-based wizards didn't work for me. I imagine that. So the wizard implementation updates the URL and then treats it as its own state. Then the user or some external script updates the URL, and you're screwed. Redux-only implementation doesn't work because Redux is an infinite state machine. History blocking doesn't work. And it brings me to what worked for me. So not to come empty-handed, I created a bicycle shop demo.
2 minutes.
Yes, that's more than enough. So you can try it for yourself at home. I've published all source code on GitHub, so you can see exactly how this state machine works and all of my thinking. It's an opinionated piece. You might approach the app like that differently, but I decided to share it because I felt uncomfortable because I wasn't sure some things were possible when I started out. For example, I wasn't sure I can save and restore user progress because I haven't seen that in the wild. There was no article about saving and restoring wizard progress. And I'm talking about clicking the back button. So the customer accidentally clicks the back button, then tries to come back, and they end at the start of the wizard. So I wanted to avoid that. And Xavier and I were able to implement it successfully in our production projects. I didn't have enough time to implement it here, but I'm planning to expand this demo. So if it's visible to you, we have this initial state, select bicycle type, then we have a back next button. Back button is disabled because there's no previous step. You can see a notes on the side, it says wizard's path, and you can see that the URL stays the same. It's at the root. So when I click next, wizard path updates to loading, and you can see that nothing is visible. So you cannot accidentally click next button during loading. which could bring you to limbo in any other setup. And you can see that it updates every time. And to show the state jumping, I'm really short on time, and unicycle. So if you select a unicycle instead of a regular bicycle, and click next, you get immediately, after the loading screen, you get immediately to the final order node step, essentially skipping five optional steps for this model. Because on previous screen, let me try clicking back, you can see that it has only single selection. There is only default selection. There's no need for you to go through all these shenanigans to order a unicycle. You can just go in and order a clown hat for complete set. And then a summary. Yeah, I'm really short on time. I guess it's question time.
Great applause. And only 3 minutes for questions then. So, are there any questions? Yes.
Fair enough.
Okay, so you didn't actually show any code, but I have a very specific question about, because you said React is infinite state, right? How do you avoid it if you have a input field? Because the input field is essentially in of itself, right, an infinite state machine.
That's a very good question. So your question, how do I store the form information and keep it finite, the states finite? I cheat. I use Redux for storing all the data, the actual input, but I have finite states for the wizard itself. So the wizard state contains only two things: the name, the path, the URL, and a possible error. So it's either error null or an error object. So it's deterministic, and it determines its state by a set of rules inside the code. I provide all the code on GitHub. You can take a look. You can file an issue. I would be happy to help. I would be happy to improve my app if you find any gaps or like limbo situations.
Awesome. One more question. There was.
Okay, so you said that you were able to save the state of the state machine, yeah? For example, you was able to save it and then restore the state after, for example, reload. Yeah, it was possible?
Yes, in our production projects for the client, we've done exactly that. Xavier might take a minute and share the actual our business achievements as a lightning talk. Yeah. Yes.
All right. So I have an idea. I don't know if you did the same, but for example, if you store each step that user did as a comment, you can after that save it and replay that everything to provide the same state as the user was in the particular situation. So
thank you. You said exactly what I wanted to say, but I didn't have enough time. Essentially, the only way to restore user progress is to replay the steps. So you programmatically go through all the through all the steps inside the machine instead of the user clicking on the next button. And we have determined your saved state might be incomplete or might be invalid. And in this case, you find the furthest step, the one you try to go as far in the journey as possible. And if you cannot reach the finish, you just settle on the next best step. Yes.
Thank you very much, Illarion. Great applause.
Thank you.